Okay, so this is my mini sonar project. It's inspired by the ANTPS 80 Gator, which is a ground air task oriented radar that I used to work on in the Marine Corps. And instead of using radio waves, this one uses ultrasonic sound waves. My initial intention was to build a 3D model and print that out and kind of stick all the parts into there, but I had lots of issues, and as you can see, possibly a small issue there with the balance of the top part of the sonar. But anyway, basically how this works is the sensor on the face of the array, once it turns back around, you'll see the ultrasonic sensor, the HC-SR04, and it sends a sound wave out of the right cylinder, and then it receives that sound wave out of the left cylinder, and then sends that data to the Arduino, and the Arduino sends that data to the IDE called processing, which is what draws the planned position indicator on the left, which is the green and red radar, kind of like Doppler radar. The code on the processing IDE is capable of keeping the object where it's last detected, and also giving you a range and azimuth of where that object was last detected. With the drag of the radar at the moment, it's not quite accurate. So right now it should be hitting those tennis balls again, but that drag of the boxes there is creating a little bit of error in the azimuth reading. Its farthest range is about 20 centimeters, 14 effective, I'd say. So there's a few main components to this project. We have the power supply, the Arduino, the stepper motor power board, the slip ring, the stepper motor itself, and the ultrasonic sensor. So power supply, pretty straightforward. The Arduino, it's taking the signals that the ultrasonic sensor is sending and receiving. So the slip ring is what makes this spin 360 degrees and also send and receive data from the ultrasonic sensor. Without that slip ring, you wouldn't be able to go 360 degrees because the servo motor is limited, has limited degrees of motion, and it also doesn't allow power to be sent through it.